if you can make organic carbon, what is the inorganic carbon that you make? And we're going to tell you what that is. Inside this resin is a rock that was formed from the process, and we sliced it in half, polished it, and had an electron microscope backscatter find out what is actually inside these rocks, these little nuggets. And here's what we found out. We found out that this is dense carbon, iron, carbon, and aluminum with a little bit of nickel and oxygen. This is a synthetically grown meteorite. Now, you're probably thinking, that's crazy, but it's not. It's totally not crazy. And this is where my Astronomy 101 from the University of Washington is coming back full circle. Okay, so the sun, our sun. I'm so sorry. Okay, now this is a rough drawing of our solar system. Out here is a place called the Kuiper Belt and the Oort cloud. It's way out there. What is out there, though? We know that there's actually stuff in the Oort cloud. And that stuff is sand mixed with frozen water chunks. They're about the size of your hand. And some are as big as this room. But way out there in the lonely space, there's water that's frozen and sand glommed together, like a snowball. And every snowball that you grab off the ground, sometimes you get like little particulates of rock in it, right? Now here's what happens. This is what's so cool. Let's say one of these little rocks, they get hit by another rock and they go, whoa! And they come in to the inner solar system. Here's what happens to that rock. It starts out as a snowball. This is called a carbonaceous chondrite. It basically is an undifferentiated snowball rock. It's frozen. As it comes into the outer solar system and into the bigger planets, it transforms slightly. Those little particulates now start forming more in the center. Here's another interesting thing. As it's falling into the inner solar system, it's emitting X-rays, 1 keV. Ever so often, pop, 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 pop. It's popping popcorn, getting closer, being pulled in to something. Okay, it gets to Jupiter. Jupiter's got a pretty strong gravitational flux. And all of a sudden, it starts forming a core. And yeah, you have a couple little things like that there and there, but you start getting a core now. This is now becoming a differentiated rock. Okay? Now, it goes by the sun now. Oh boy, the gravity is really strong there. What happens is this. It turns into Fe3O4. What it does. And the shape, the nanotechnology shape of this is, it's a diamond. It's a carbon diamond, basically. And this is the definition of a meteorite. A meteorite is aluminum, carbon, see, iron, and nickel. So as it's falling into the gravity well, it's transmutating into these elements, and that's what a meteorite is. Okay, all right. Now we have this snowball that turned into a meteor, which is iron-based, and then it gets kicked around the sun, but it gets kicked around the sun in such a way that it gets shot to Earth. And then this meteorite actually goes through our atmosphere and then burns up. And it gets the fusion crust, okay? But when we take that rock and we look at it, it's iron, carbon, and all these other elements. But came from water, frozen water. That's important, because that's what we put in our devices, water, okay? So what I'm saying is, why is that important? We know the process now. Why is this thing important? What can we use the meteor for? Dude, this is insane. If you take the meteor that you synthesize using our proprietary quantum kinetic well phenomenon, and you take that meteor that has no fusion crust on it yet, and you expose it to temperatures, heat, you try to burn this thing, guess what it turns into? A giant flame of energy, and the byproduct is H2O. It burns and then turns back into water. It's a time crystal. And by the way, Google has been trying to figure out what a time crystal is for the last 10 years. I even met with the CEO of quantum computing and cold fusion at Google. He didn't tell me what it was. I know what it is. It's a time crystal held together by gravity, and then you can burn it and it turns back into water. That's a time crystal. It's a meteorite. It's a meteor. We don't even know what meteors are, what they do, but they're more valuable than gold or silver. The price point on them are huge, but we don't know what they're used for yet. I do. You can use them in coal power plants to make clean coal. You can synthesize clean coal. That's what a meteor is. It's clean burning coal. It's just like if you burn a hydrogen-oxygen gas. We actually think that this thing that we synthesize with our technology is a hydride. What's a hydride? Well, a hydride is basically something that a chemical or a physical structure of the atom that holds on to extra hydrogens on the outside, a hydride. By the way, hydride technology can be used for storing hydrogen in tanks for cars or tanks or whatever, right? Hydrides are a big deal. You can stuff them into a tank, heat it up, and then it will release the hydrogen safely for use. So this is basically a hydride technology that you can just burn, and then it releases the hydrogen. And actually, I have 2 samples. I burned it, and then I didn't burn another sample and took them to the UW and had them analyzed. The structure does not change during the burning process. With a butane torch, high temperature, blows off a whole bunch of heat, and you look at it under a microscope, it's the same physical structure still. It didn't change, but it released a bunch of hydrogen because it's a hydride. And I don't know if there's a point where it starts disintegrating in something else, but that's what it is. And when you take a meteor and you have it fall down into the earth, it gets that fusion crust. Well, now it's no longer a hydride anymore because you basically overexerted the hydrogen plucking, basically. So, yeah, it's pretty crazy. It's basically the answer to everything.